All right, I apologize for not getting through the notes yesterday or whatever day. I guess I don't know what day you're watching this, but I had a request or two to finish a couple of examples from the notes. So if you have questions, and hopefully you found this video and found it helpful. So I'm going to do this example here, which was simply to graph this function. First of all, I notice that there's a negative inside the sine function. We don't want to flip it over the y-axis. That's kind of difficult, so we want to avoid it. So we're going to use the even and odd functions. If you recall, the sine of negative x is negative sine x. So I can essentially just take that negative out of there. For the cosine, you don't do that, but for this one, you can. So if I take this negative out, it's basically going to change that negative outside to a positive. So this is going to be 3 sine x over 11 minus 6. Okay? Now let's find the properties of the graph. The amplitude is going to be 3. The period is going to be 2 pi over 1/11, which is 2 pi over 1 times 11 over 1, which is 22 pi. And then I need to shift it up 6 units. Excuse me, down 6 units. All right, so let's start with the period. I'm going to mark off one period. That's going to be 22 pi. Then I'm going to divide that into 4 parts. And then I'm going to do a few tick marks on each side to get some extra graph, extra periods, whatever you want to call it. All right. Now, the difficult thing on this problem, perhaps, is handling the shift up, down 3 with an amplitude of, down 6 with an amplitude of 3. So basically, if I go down 6, and then it's going to kind of go up 3 and down 3. So it's going to kind of look like that. So it's going to be a little strange. So what I'm going to do is I'm going to scale this. If I go down 6 and then down 3 more, I got to go down to about 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to draw a new x-axis, like a shifted x-axis, 6 units down. 1, 2, 3, 4, 5, 6. So kind of right here. So I'm going to graph this function basically as if this dotted line was my x-axis. That's down 6. So the sine function is starts at 0. So 0. And then on the first tick mark, I'm going to go up 3. So that is going to go to negative 3, back to 0, down to negative 3, back to 0. Getting it spaced out a little bit here, sorry. Back to 0, up to 3, back to 0, down to 3. And then on the back side, down, up, up. Not perfect, but certainly good enough. And then kind of connect it with a nice, smooth, rolling wave curve. Okay? Not perfect, but good enough. All right, graph. Then the other one, I did this one in class. This is the other one I kind of missed. I think there was probably one more too. I think I didn't do this one. Maybe I'll do that one at the end as well, but we'll see. 3 minutes. Okay, here we go. So this one here. To do this one, we basically need to find, this is going to be a cosine. The sine starts at 0, cosine starts up at 1, so it makes it easier to find a cosine. Basically, I need to know what number is out in front, and then I need to know what number is out in front of that x. There is no phase shift, there's no horizontal shift, and there's no shift up and down, so I don't have to worry about adding or subtracting. So really, I just got those two numbers. The amplitude is the distance from here to here. That is 4, so put a 4 out there. And then this is going to be that b value. That b value is determined by the period. So I need to figure out a period. I want to go from here to the other peak, but I can't see the other peak. So I guess I'm going to go from here to here, see what that distance is. Well, this distance is pi force. This distance is also pi force, or negative pi force. Distance is pi force. So basically, if you double pi force, you get 2 pi force, also known as pi halves. That's the period. So the period equals pi halves. The period also equals 2 pi over b. So if you solve this equation for b, you get the number that needs to go right there. Okay? I'm going to multiply by b, and I'm going to multiply by 2 over pi. B's cancel, 2's cancel, pi's cancel. So b is equal to, let's be a pi, 4. There we go. So my equation is y equals 4 cosine of 4x. So find the period, find the amplitude, use the period to find that b value. Okay? We're only at 5.5 minutes, so I guess if you want to stick around, I will do this last. I think this is the last example I skipped. So that would mean our notes are complete. So this is going to be one of those tricky ones. This is going to have a phase shift, a horizontal shift. However, it is not pi 6 units to the left. You need to remember to factor out that coefficient of the x. Inside needs to be factored. So negative 100 cosine, take out the pi thirds, x plus. Okay, so this is going to be a little tricky here. I don't know. I guess if you can see it, it's just, I guess I can just see kind of a 1/2. I don't know if you guys can see that, but basically if I take a pi thirds out of pi 6, it leaves me with a 1/2. What you're really doing is you're taking that pi 6 and you're dividing by pi thirds. And if you take pi 6 times 3 over pi, you get 1/2. Double check it. If I multiply this, do I get pi 6? Yes, I do. So I'm right. Okay. So you got to factor out that inside. So this is x. So now let's identify the important characteristics. The amplitude is the absolute value of 100, which is 100. The period is 2 pi over b, which is pi over 3. That's 2 pi over 1 times 3 over pi. Period is 6. And then my phase shift is negative 1/2 unit to the left. That is negative 1/2. Phase shift is a number. Please don't forget that. All right, so that's the stuff I need. And then it's a cosine. So let's mark off a period. Period is 6 divided into 4. Do some extra tick marks on each side to graph a little bit more of the function. I'm going to graph 3 full periods this time. Now I do need to figure out this phase shift of negative 1/2. Therefore I need to kind of figure out what the tick marks are. So 1/2 of 6 is 3, and 1/2 of 3 is 3/2. So 1 tick mark is 1.5. So 1/2 of a unit is going to be 1/3 of a tick mark. So this is going to be like 1/3 of a tick to the left. Okay, so that's kind of what my shift is going to be. So I'm going to graph the base function, then I'm just going to move everything 1/3 of a tick mark over. Okay, so the base graph would be cosine, which normally starts up at 1. I guess I should go up 100 and down 100. Normally the cosine starts up top at 1, but this has got a negative, so I'm going to start down to do the flip. So it's going to start down here, and it's going to go up, up, down, down, up, up, down, down, up, up, down, down. Now that's not actually my graph. I still need to shift it. In fact, you could actually move those points over if you wanted to and not even graph the other. But I do, on phase shifts, I kind of do like to see, I don't know, I just like to see the 2 graphs that are out of phase. So I'm going to do this as a dotted line, kind of as an intermediate graph. And then I'm going to do my actual graph, 1/3 of a tick mark to the left. So every point gets moved over 1/3. So that's 1/3 of a tick mark. 1/3 of a tick mark. As accurately as you can, of course. This is it's all kind of an approximation. 1/3 of a tick mark, 1/3 of a tick mark, and then kind of redraw it. It's basically just going to be, oh, this tick mark was in the wrong spot. Oh, I got it. So here we go. And you can see it's just out of fit. And that's the phrase that we use in, I don't know, physics or math, I guess. You know, it's out of phase. It's just It just shifted slightly from the original. That's called, those two waves are called out of phase with each other. They're not in sync, I guess. Okay?